Okay. Hello, everybody. My name is Gianluca Mardente. I'm a principal engineer at Cisco, and my talk today is about how to manage Kubernetes add-ons for multiple clusters using cluster runtime state. We started this project because we were using cluster API on-prem to bring up a bunch of Kubernetes clusters on demand. So our goal was to create a cluster, upgrade the cluster, delete the cluster when we were done. When you bring up Kubernetes, pretty much you know that after you have a Kubernetes cluster now, you have to start installing like a bunch of add-ons. You need like a CNI. If you want to have network policies that dictates who can talk to whom. You need to have like Prometheus if you want to collect metrics. You need to deploy your own applications. And there are other tools today already, Flux, Argo CD, Ranger Fleet, if you're using like Ranger, to deploy add-ons. And Sveltos wants to be like a solution to easily manage and deliver cluster add-ons to tens of clusters. As I mentioned, we started this project, we're using cluster API. So there is a management cluster. And from this cluster, all the managed clusters are reachable. And the idea behind Sveltos is that you install Sveltos in the management cluster, and then you use a Kubernetes label selector to select a set of clusters. And then you simply list all the add-ons that you want to be deployed, and then you let Sveltos do the work. And Sveltos pretty much is going to deploy like all those add-ons. And on top of worrying about like taking care of scaling the number of clusters they can manage, Sveltos also wants to give you like at any point of time an exact view of what add-ons is deployed on which clusters and where. So those are the two main goals. The cluster profile is the CRD that is introduced to instruct Sveltos on what to do. And it has like three main fields in the spec section. The cluster selector, which is a simple Kubernetes label selector. So in this case, in this example, it is selecting all the clusters which have labels environment equals to FE, which stands for functional verification. And then it has an Helm chart section where you can list all the Helm charts that you want to deploy. And then it has like a policy ref. Policy ref, it's simply pointing to config map and secrets. And each one of those reference config map and secrets in its data section can contain like Kubernetes YAML resources. So Sveltos can take any resources contained in any config map data section or any secrets data section and deploy like in the cluster along with the Helm charts. So I have an example here. We have a management cluster. And inside the management cluster, we have cluster API because we use cluster API to bring up new clusters, new Kubernetes cluster, and we have Sveltos. And then I'll simply post to the management cluster this cluster profile, which is selecting all the cluster with environment production, and it's simply asking to deploy Caverno Helm charts version 2.5.0. As soon as we add a label environment production on one of the cluster, Sveltos detects that this cluster is now a match for the cluster profile. It takes all the resources, Helm charts, in this case it's just Caverno, that are listed in this cluster profile and deploys in that cluster. Likewise, if we add the same label on the second managed cluster, Sveltos is going to do the same cycle again. It detects this cluster is a match for this cluster profile, and it deploys Caverno in this other cluster. And same way you deploy, you ask Sveltos to deploy resources like add-ons in a cluster, you can ask Sveltos to remove resources from a cluster. So what happens if we remove like the labels environment production from the second cluster? Now this cluster is not a match for the cluster profile anymore. And so Sveltos simply goes and removes all the add-ons that had deployed in this cluster because of this cluster profile. This is a little more complex example. When you deploy Calico in a cluster, not sure if that is still a requirement today, but at least it was a requirement in this version. You had to tell Calico which is the pod header for that cluster. Which means that we need some sort of template, because we want to create a simple cluster profile that says like install in all the clusters with the label environment production, install Calico. But Calico requires like to know the pods either, so we need some sort of templatization. If you're familiar with Cluster API, when you create a cluster with Cluster API, there is a cluster instance in the management cluster, and that cluster instance contains, in the spec, cluster network pods CIDR blocks. It contains the CIDR blocks allocated for that cluster. And so with Sveltos, you pretty much, what we are saying, like in this example, we are asking Sveltos to deploy Calico, but at the time of deployment, before deploy, take the information from the cluster instance, the management cluster, takes the pod CIDR, which is present at management cluster source, use it to templatize this template, and then deploy. And this applies to both like Helm charts and Calico, and any type of resources which is containing config map or secret that are referenced by Sveltos. Some resources are fetched by default from the management cluster by Sveltos, and those are all the resources that represents a cluster. So if you're using Cluster API, there is a cluster instance, there is an infrastructure provider instance, there is a kubeadm control plane, which contains some other information. Sveltos, though, is not limited to manage Cluster API Power Cluster. Essentially, if you have a GK cluster, and your GK cluster is, for instance, reachable from your management cluster, you can register this cluster to be managed by Sveltos. Pretty much like there's going to be like a Sveltos cluster instance representing this cluster in the management cluster. This is also fetched by Sveltos when deploying add-ons in the managed cluster. But we don't know all the possible use cases. So Sveltos can also be instructed to fetch any resources which is present in the managed cluster and use those values to instantiate the add-ons before deploying it. So in this example, what we are saying, we are asking to get a secret, which is present in the default namespace, and it's called autoscaler, and identify this resource with the key autoscaler secret. So if the config map contains a template, this template, simply using this autoscaler secret, can fetch any value which is present like in this secret. And this is true like for any resource that is present in the management cluster. Now, because we are dealing with a lot of cluster and a lot of add-ons, sometimes like it is nice to preview what the outcome of a change will be. If I'm deploying a Helm charts and I'm going to touch like a cluster profile, I would like to know what cluster is going to be affected by the change and how. So Sveltos has this sync mode where you can set like sync mode in dry run. When the sync mode is set in dry run, what it means is we are asking Sveltos to run his entire logic, so find all the clusters that are going to match the cluster profiles, pretend that it's going to deploy all the add-ons like Helm charts or the content of the config map and secrets, but do nothing to the managed cluster. Simply let us know what the effect is going to be. So for instance, like if I change the cluster profile that I listed before, no change is going to happen like to the managed cluster, but then I can ask Sveltos, if I were to commit this change, what will change? And the answer is going to be that like in this cluster here, in the Sveltos management workload managed cluster, the Caverno release will change from 2.5.0 to 2.6.0, which means like no changes really take an effect like in the managed cluster. I'm simply previewing what the change will be if I were to commit this change. Now, Sveltos has other cluster, but has other features, but like the main topic of this presentation was how to use the cluster runtime state to decide which add-ons to deploy on which clusters. And so I'll go back like to the example that we had before. We have the management cluster with Sveltos, and we had like 2 managed clusters. And those 2 managed clusters are running Kubernetes version 1.24.2. The intent that I have here is to ask Sveltos to deploy, I want to deploy Gatekeeper version 3.9.0. But I want to deploy this version only if a cluster is running a Kubernetes version which is greater than 1.24.0 and less than 1.25.0. So here there is a second CRD which is used like to configure Sveltos. This CRD is called a classifier, and the classifier has a constraint section. In this case, the constraint section is simply based on the Kubernetes version. It's saying that if the Kubernetes version is greater than or equal to 124 or is less than 125, it's a match for this classifier. And if it's a match for this classifier, we are asking Sveltos to add this label here, gatekeeper v39 on the cluster. So far we were managing the cluster labels ourselves. Now we don't want to do that anymore. So we want to delegate this job to Sveltos because we want to have Sveltos change the labels using the cluster runtime state. So in this example here, as soon as I create this classifier instance, Sveltos is going to deploy a Sveltos agent running in each of the managed cluster. This Sveltos agent is going to detect that those clusters here are running version 124.2, so they are a match for this classifier. Because they are a match for this classifier, Sveltos is going to add the label gatekeeper v39 to both the clusters. Because this label has been added to the cluster, Sveltos is going to detect that this cluster is now a match for this cluster profile. And because it's a match for this cluster profile, we want gatekeeper v39 to be deployed in both the clusters. And so this is what happens. But now, let's say that I know that gatekeeper version 390 works just fine if the Kubernetes version is less than 125. But if the Kubernetes version is greater or equal than 125, I want to automatically upgrade gatekeeper to version 310. So what I can do, I can create like another cluster profile that says like if the label is gatekeeper 310, deploy gatekeeper version 310. And then I can create another classifier that says like if you see any cluster whose Kubernetes version is greater than or equal than 125, I want you to add like this label, gatekeeper v310. So if now I'm going to upgrade this cluster here, so from 124.2 to 125.2. Because this cluster is going to be is upgraded, Sveltos agent automatically detects that this cluster is not a match for the old classifier, but is a match for the new classifier. Because it is a match for the new classifier, the label is supposed to change. Now the label is not supposed to be gatekeeper 39, but it's supposed to be gatekeeper v310. So Sveltos changed the label on this cluster automatically. Because the label on the cluster has been changed, now this cluster becomes a match for this cluster profile, and it's not a match for the old cluster profile anymore. And because it's a match for the new cluster profile, we want to deploy gatekeeper v310, and so gatekeeper gets automatically upgraded. And there is no configuration that is done by us. So we simply express the intent, and then the system took care of deploying everything. There are a bunch of other features which are listed on those two slides. Essentially, the main one that some of those already touched, but the main one I want to mention why we deploy another Kubernetes Add-Ons manager. It's because we wanted to use the runtime state of a cluster to decide which add-ons to deploy, but also we need an event-driven framework to deploy add-ons in response of events happening in a cluster, and we want to have a system a way to say, even a cross-cluster configuration, a way to say is if you see an event in this cluster, this is the set of add-ons that you want to deploy in this other cluster. It has pretty much configuration drift detection and other features, but I think I'm almost done with my time, so I want to leave a few minutes if there are if there is any question. But okay, no question. Thank you so much. I appreciate you being here. Thanks a lot.